with drawing our Lewis structures, we had already done some double bonds, but we also have things called triple bonds. So I just wanted to share this with you, that a double bond involves the sharing of 2 pairs of electrons, and a triple bond is a bond that shares 3 pairs of electrons. So a double bond has 2 lines connecting the atoms, and a triple bond has 3 lines connecting the atoms. I would probably never ever, I will never say never, but usually you will not have to do a triple bond yourself. We do double bonds quite often though, like as you've seen on our Lewis structures paper. So, but triple bonds are very rare, so those won't always happen. So make sure that you write down 2 and 3 on the coordinating lines, please. Good to go? Okay. This next type of bond, I'm never going to make you do this yourself either, but it does happen occasionally, so that's why we're talking about it, okay? So carbon monoxide is an example where it's very difficult to make the octet rule apply. Remember when I say something's happy, or does it have all of its oxygens? It needs 8 normally, okay? So for carbon monoxide, we take 1 carbon with 4 dots, because it's in column 4A, and 6 dots around an oxygen, because it's in 6A, and we bond them once. Remember, the line means the bond. So when we bond it once, the carbon now has 5 electrons around it, and the oxygen has 7 electrons around it. So it's not ready yet. So what would we do next in this structure? It might be below on the paper. What? You have to do something. Connect another dot together. So when we connect another dot together, we create a double bond. Okay, and so then by creating this double bond, now the oxygen has how many electrons around it? 2, 4, 6, 8 around the oxygen, and how many around the carbon? 2, 4, 6 around the carbon. So when I ask, are they happy, on the top of page 4 in your notes, I'm asking, are the octet rule completed, applied? Does everybody have 8? Does everybody have 8? No. Oxygen does, but the carbon does not. So this is where the coordinate covalent bond comes into play. What happens is, oxygen is very generous, and it actually lets 2 electrons go. So instead of having 2 pairs of electrons left over, one of its pairs is going to move to become a triple bond in between the 2 atoms. So when we have that triple bond, then we now have down here 2, 4, 6, 8, 2, 4, 6, 8. So then it's all happy to go. Okay? That's not something that we normally think of when we're writing Lewis structures. So that's not something that I'm going to make you do very often, but it does occasionally happen. So that's why I've included it in the notes. Okay? But a coordinate covalent bond is when you have a very generous atom that will give up 2 electrons to make the octet rule completed for both atoms. Okay? We will need to know how to do polyatomic ions, though. And that's what we need to know how to do to finish up our Lewis structures assignment. So a polyatomic ion is a group of atoms that has a positive or negative charge. And so then it behaves as a unit. We are going to still draw a Lewis structure like we've been doing, but now that positive or negative charge allows us to change our total number of electrons to make the octet rule work. Okay? So before we get started, we need to remember that when it's a positive charge, like in chapter 7, when it was a positive charge, were we gaining or losing electrons? Like if magnesium has a +2 charge, that means it's losing 2 electrons. So on our pictures, if it has a positive charge, that means we get to take off electrons. So make a note to yourself saying that you take electrons off when it's a positive charge. So if it's a +3, you take off 3 electrons. If it's a negative charge, we said in chapter 7 that it's gaining those electrons. So that means we have to add the electrons to our picture. So if it's positive, we're going to be taking them off, erasing them, or crossing them out. If it's negative, we are going to be adding additional dots in order to make our octet rules apply. Okay? And usually, the octet rule is followed by the outside ions, or outside atoms, and then the central atom is the one that sometimes breaks the rules. Okay? So the first one we have is NH4 plus 1. So what's going to be our central atom here? The nitrogen. How many dots around a nitrogen? 5. Okay. Then each hydrogen donates 1 to the group. And I need to add 4, but I know right now, like, hey, those 3 dots by themselves, I'm going to add 3 of my hydrogens there. There's 1, 2, 3. Where am I going to add my 4th one? On the top. So you have to pick one of them to add it to. So I'm going to pick the left one, just because. Okay. But when I do that, I have this electron hanging out by itself, and it's not in a pair, so it's not, it can't stay there. This is where the charge comes into play. Okay? When it has a positive charge, we are taking the electrons off. So we have a plus 1, so that means we get to get rid of 1 electron. So if you have an eraser, you can just erase it. If you have a pen, you can always cross it off, like on the answer key, or you can just not put it if you realize you're going to do that. On the answer key, I always exit just so that it's easier for you to realize that I took that one away. But by doing that, then nitrogen, is nitrogen good with 8 electrons? The hydrogens are all okay? Yep. Last thing we have to do is we have to put it in brackets. So you put the whole entire structure into brackets. And then after you have it in brackets, you're going to put the charge in the top right corner. The reason why we do this is just so that when I or any other person just looks at your paper and we see the brackets, then we know that you did something to the total number of electrons to change it, to make it work out. The way you check yourself, and people have been asking you, what do these numbers mean? Like, why do we do this? The whole adding and subtracting thing to figure out our total number is the way you check. So we said nitrogen has how many dots? 5. And then each hydrogen had 1, and so it's 4 times 1. Then, so that equaled 9. But then the plus 1 charge helped us to take 1 away, so I can subtract 1 to get 8 electrons. Do we have 8 electrons in our structure? Yep, so we're all good to go. Okay? Let's do the next 2. The next 2 are negative charges, so that means we are going to add dots somewhere. Okay? So we have CO3 minus 2. Carbon, how many dots? 4. And then just go ahead and draw your 3 oxygens with 6 dots each somewhere. After you've drawn them, then connect all the oxygens once to the carbon. It doesn't really matter where you connect them. Okay. Before we do anything with the adding, we can still get things taken care of. The carbon currently has 1 electron left over by itself. What can I do to make the octet completed around the carbon? Add another line from a carbon to an oxygen. So you pick one of the oxygens. Doesn't matter which one. I usually pick the closest one, so it looks nice. And you're going to create your double bond by connecting that oxygen again. So by doing that, creating that double bond, we now have 2, 4, 6, 8 around this oxygen, and we have 2, 4, 6, 8 around the carbon. So 2 out of our 4 things are good to go. But the other 2 oxygens have 7. 2, 4, 6, 7. 2, 4, 6, 7. So this is where our adding on electrons comes in play. Okay? We have a -2 charge, so we can add on 2 electrons. We're going to add on 1 electron to each oxygen to make them have a total of 8 now. Okay? So I'm going to add 1 there and 1 there. So now we have 2, 4, 6, 8 total around that. Okay. Sometimes people like to use a different color when they add that dot on. Sometimes they like to circle it. Sometimes they like to make it really big. It doesn't matter to me if you want to distinguish it from the rest or not. I just need to be able to see it. That's the most important thing. So make sure your dot is readable. And if you put brackets with your charge, then I know to be looking for dots that you added on. Okay? Questions? Do we need to check it? Okay. Last one, NO3 minus 1. N had 5 before, so we're going to still do 5. Oxygen still have 6 to start. Then once we draw those out, we'll connect all the oxygens once. What should we do next? We can, yep. So we have a -1 charge, so that means we get to add 1 dot somewhere. So where should we add that dot? To one of the oxygens. So I'm going to pick my bottom oxygen just because. So that's where I added. So now I've added my 1, and now I can't add any more. But by adding that 1, I made the bottom oxygen on my picture have 2, 4, 6, 8. But do the other oxygens have 8?
No.
No. What do I do?
The dots on the
Yes, we have to break up this unshared pair and make double bonds. So by doing that, we make the oxygens happy with 8, but the nitrogen is breaking the rule. And that's okay, because only the central can break the rule. The outsides need to still have 8. Last but not least, brackets, -1 charge. Because it's telling me that you have done something with your dots. You've changed the total number of dots that you're supposed to have. Okay? So we can now finish our Lewis structures paper.